In 3.4, we're going to be looking at the factor theorem and the remainder theorem. But before we even get to that, we need to review our long division and our synthetic division. How do we actually divide these polynomials out? So hopefully this will be a refresher from your college algebra. So when we're doing long division, you want to first set it up. And so I'm going to go ahead and draw my division bar here. I'm dividing by x minus 2, so it's going to go out front. I'm dividing 6x cubed minus 19x squared plus 16x. Now when you're writing in your long division, you always want to put it in standard form. Start with the highest exponent, work your way down, and put in zeros anywhere you're missing a term. So I have a cubed, squared, linear, and my constant. So I have it all set up. Now when you're doing this, you want to compare your front numbers as you divide. So I'm only going to look at x and 6x cubed to figure out what I need to put on top in order to divide this. So you're going to compare, and you're going to say x times what would give me 6x cubed, and that would be a 6x squared. I'm going to place it above my other squared here, and that's just going to be a placeholder to remind me that I may only have to do this 2 more times after this. After I figure out what times x will give me 6x squared, I'm now going to multiply it. 6x squared times x gives me 6x cubed. 6x squared times negative 2 gives me negative 12x squared. I'm going to line up terms underneath the terms that have the same exponent, and then I'm going to subtract this whole thing. Now I'm emphasizing subtracting this whole thing, and so I want to change all the signs because my goal was to get in exact terms so that when I subtracted it, 6 minus 6 would cancel, and then I can work my way down from there. So negative 19x squared plus 12x squared would be negative 7x squared. And then bring down the next term, so plus 16x. And then you're going to compare again. X times what would give you negative 7x squared? And that would be a negative 7x. You can see I'm placing it above the term that has a singular x on it. Then you're going to multiply. So negative 7x times x gives me negative 7x squared, and it should. That's the reason I picked it. Negative 7x times negative 2 gives me a positive 14x, and I want to subtract this whole thing. And so I'm going to change all the signs. This should cancel, otherwise I picked a bad term. And then combine these to give you a 2x. And then you bring down the next term, so plus 0. Then you compare them again. X times what would give you a 2x? And that would be a positive 2. You can see I'm lining them up. Now that I only have this spot that was left, I've taken it. This will be my last step, so it's just kind of a check mark along the way. Then we'll multiply. 2 times x gives me a 2x. 2 times negative 2 gives me a negative 4, and then I want to subtract this whole thing. So I'm going to change all the signs. 2x minus 2x cancels. 0 plus 4 is just 4. Now if you get an answer here, 4 will never multiply to give us x will never multiply to give us a 4, so this is my remainder. I also notice I don't have any places to put a number on top here, so I'm just going to say plus 4 over whatever you're dividing by. Let's do another one and kind of make it a little bit harder for you. Hopefully this is coming back to you. So again, I'm going to set up my division bar. I am dividing 2x to the 4th plus x cubed. Now I'm going to put a placeholder for x squared because I don't have one, minus 7x plus 4. I'm dividing it all by x squared plus 3x minus 2. So again, we're going to do it the same as when you're only going to compare these front terms. And so I'm going to say x squared times what would give me 2x to the 4th, and that's a 2x squared. I'm going to put it above my other x squared term so that I know I only have to do this 2 more times. Then we'll multiply. 2x squared times x squared gives me 2x to the 4th. 2x squared times 3x gives me a plus 6x cubed. 2x squared times negative 2 gives me a negative 4x squared. You can see having this placeholder really helped me to keep me organized. Then I'm going to subtract the whole thing. So I change all the signs. You can see this would cancel, leaving me with 1x cubed minus 6 would be a negative 5x cubed. 0 plus 4 gives me a plus 4x squared, and then I can bring down the next term. Then you're going to compare again. X squared times what would give you negative 5x cubed? And so that would be times a negative 5x. So we figured out what to put here. Now I'm going to multiply it by everything out front. Negative 5x cubed. If this didn't come out to be exactly the same, I picked the wrong term. Negative 5x times positive 3 gives me a negative 15x squared. Negative 5x times negative 2 gives me a positive 10x. And then I want to subtract this whole piece. And so I'm going to change all the signs. So this cancels, and I have 19x squared minus 17x, and I'm going to bring down the last term. And I'm going to compare again. X squared times what would give me 19x squared? And that would be a positive 19. It's placed above the 4, so this is going to be the last time I have to do this. 19 times x squared gives me a 19x squared. 19 times 3x gives me 57x. And 19 times negative 2 gives me a negative 38. And then I'm going to subtract that whole thing. So I'm going to change all the signs. This would cancel. This would give me negative 74x plus 39. And x squared is not going to create that, so that would be my remainder. Negative 74x plus 39 all over x squared plus 3x minus 2. Now don't freak out when you get remainders like that. It's okay. Just keep working forward and plug it in and see if you're correct. Oh, I apologize. I must add it right here. I know you've probably done the same before. This is actually going to be plus 42 plus 42. Now that we reviewed our long division, let's go into our synthetic division and review that. Remember, when you're setting up your synthetic division, you're going to flip that division sign upside down. You're going to take what you're dividing by. It has to be an x plus or minus number, and you're going to go ahead and solve it out for 0. So I'm going to say x plus 3 is equal to 0. Moving that 3 over, get x to be negative 3, and that means negative 3 is what's going to come out front. Now synthetic goes a lot quicker, only working with your coefficients, but same rules apply. Put them in standard form of decreasing exponents, and it is crucial on synthetic that you put zeros anywhere you did not have a term. So 1 is going to be my coefficient on x to the 4th. I don't have an x cubed, so I'm going to put a 0. X squared is going to be negative 10. X is negative 2, and then 4 is my constant. So I'm only writing the coefficients. Now this goes a little bit quicker. You're going to bring down the first term. You're going to multiply these two together. Negative 1 times 1 gives me negative 3 times 1 gives me negative 3. And then add vertically to give you negative 3. Multiply to give you positive 9. Add vertically to give you negative 1. Multiply negative 3 times negative 1 to give you positive 3. Add vertically to give you 1. Multiply gives you a negative 3. Add to give you 1. And this would be your remainder. Again, that went really quickly. We started out as an x to the 4th. We're dividing by that singular term, so it just reduces it by 1. So this would be x cubed, x squared, x, constant, and then your remainder. And so my final answer would be x cubed minus 3x squared minus x plus 1 over x plus 3. And so you can see synthetic division definitely goes a lot quicker for us, and you're going to see us using that synthetic quite a bit. Now here's one of the high points of this section, the remainder theorem. It states if p of x is a polynomial of degree 1 or greater and c is a real number, then when p of x is divided by x minus c, then the remainder is p of c. So what's going to happen is when you're doing that synthetic, whatever you get your remainder to be would be just as if you had plugged c into your equation. And so from our example above, we would be able to see that when we were dividing using x equal to -3, the remainder was 1. So by the remainder theorem, p of -3 would be equal to 1. So we could check that. We could say p of -3, and we could plug -3 everywhere into the original function. So I'm just replacing the x's with -3. So let's see, that gives me 81 minus 90 plus 6 plus 4. And you can see that gives me the same remainder that I got from above when I did synthetic. So pretty interesting just kind of theorem that results from looking at synthetic and working it over and over. Let's go on to this next concept, finding zeros and complete factorization. So in step 4, what we want to do is we want to find all the zeros of x cubed plus 4x squared minus 5x minus 14 that has a factor of x minus 2. So knowing what we know about polynomials, we know that since the highest degree is 3 here, that will be at most how many zeros I get. And since it tells me it has a factor of x minus 2, they're telling me that's my starting point. So what I'm going to do is I'm going to do synthetic division. So I'm going to plug in my polynomial 1, 4, -5, -14. And then I'm going to go ahead and divide it by a factor of x minus 2. So I'm going to take x minus 2, say it equal to 0. It gives me 2, so that's the value I'm going to put out front. I'm going to work my synthetic, multiplying and adding the whole way. You can see I got a remainder of 0. Now they told me it was a factor of x minus 2, so if I don't get a remainder of 0, then I did not do it correctly. And so then let's look at our result. We would have x squared plus 6x plus 7. And so what we want to do is look at the remaining result, and I want to find all the zeros. And so here's 1 0, and I need to find 2 more. So if what you get at the very end doesn't factor, and I can't spell that correctly for the moment, if it doesn't factor, then you want to use your quadratic formula. And so we're going to have to do that here. So let's see, my a is equal to 1, b is equal to 6, and c is equal to 7. So I'm going to say x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to plug it in. That gives me -6 plus or minus the square root of 6 squared minus 4 times 1 times 7 all over 2 times 1. Cleaning that up, that gives me x equal to -6 plus or minus the square root of, I'm just going to plug all that in my calculator right there, and I get a value of 8 over 2. I can see that that would be -6 plus or minus 2 square roots of 2 over 2. And then that would shorten to -3 plus or minus the square root of 2, just reducing those 2 by 2. And so by using the factor that they gave me and using my quadratic formula, I'm able to get all my zeros. They would be 2, -3 plus the square root of 2, and -3 minus the square root of 2. You can see I got 3 zeros, and it was a third power polynomial, so that follows suit. Now these are really good test problems, and when given in the test, I am going to give you some kind of jumping off point of here's a factor, or here's a 0, and then you'll have to complete it from there. Let's look at this next one. It says write the complete factorization of the polynomial and list all the zeros, knowing x minus 2 and x plus 3 are factors. So that's going to be my starting point. So I'm going to go ahead and set up my synthetic. I have 2, 7, -4, -27, and -18. So I'm going to use this first factor here. X minus 2 I set equal to 0 and solve, and that gives me 2. So 2 is going to be on the outside. I bring it down. I'm going to multiply and then add. Multiply, add, multiply, add, multiply, add, and I get 0's remainder. And I should, because they said that that is a factor. Now when you go to do your next factor of this x plus 3, Start with where you left off. Do synthetic again on your result. So I'm going to take x plus 3 equal to 0, and I'm going to solve it out, so it gives me negative 3. So it's going to go on the outside. Bring the 2 down. 2 times negative 3 is negative 6. Add, multiply, add, multiply. And again, I get a 0 as a remainder, showing that there's a 0 with a function. And again, they told me this was a factor, so it should work. Now, when you're looking at this was an x to the 4th, and then it became an x cubed, and so now it's an x squared. Once you get it to the point of a quadratic, you can take the result, which is 2x squared plus 5x plus 3, and you can factor it or quadratic formula it from there. This one actually works out to be the factors of 2x and x, and then plus 3 and plus 1. And so then it asked, write the complete factorization. That would be x minus 2, x plus 3, those were given, 2x plus 3, and x plus 1. This is the complete factorization. It also said to list all of the zeros, and so the zeros would be x equal to 2, negative 3. I would just take these and solve them out. 2x plus 3 equal to 0. That gives me 2x equal to negative 3. So x is negative 3 halves. And then x plus 1 equal to 0. So x is equal to negative 1. And so you can see synthetic is going to be really handy as you're working through and breaking down these polynomials. So I hope this helps with this section. If you have any additional questions, please let me know.